In this video, we will be discussing the concept of acceleration. In the previous two ones, we talked about the differences between distance and displacement, and also speed and velocity. Now, in physics, we define acceleration as the change in an object's velocity divided by the time the change takes place. It is a vector quantity. And why is this a vector quantity? Because it is defined through velocity. It is a change in velocity. And we know from our previous video that velocity is a vector quantity. Why is velocity a vector quantity? Because it is defined through displacement, who happens to be another vector quantity in physics. So far we have identified three of them. Soon you will identify even more, which means that they require not only the magnitude to be defined, but also a direction. Now, the units in the international system for acceleration are meters per second squared, which you will also see as meters times second to the power of minus 2, which is a different mathematical way to write this down. Now I'd like to talk about the symbol for change that we're using in physics and mathematics quite often. It's the Greek capital letter delta. If you want to pronounce it properly, it's delta. Quite often we use it as delta. In any case, that's absolutely fine. It basically means change in something, change in a quantity. We can have delta V to talk about change in velocity. We can have delta T to talk about change in time. We can have delta X to show the change in position or displacement. And in general, the delta of x being any quantity that we can define, okay, is the value of this quantity in the final position, the final position in time minus the initial one, okay? And this will become clear now through some examples that I have. So the change in velocity, delta V, is defined as V minus U, where V, we're using it for the final velocity, and U, we're using it for the initial velocity. Now let's look at an example. An object accelerates from 10 meters per second to 20 meters per second in 2 seconds. Find the acceleration. So it says it accelerates from 10 to 20, which means we can already identify that the final velocity is going to be 20 meters per second and the initial velocity is going to be 10 meters per second. The time taken is 2 seconds as it's given in the exercise. So let's calculate acceleration. Acceleration, as we said, is the change in velocity over change in time. So change in velocity is the final minus the initial one. So 20 minus 10 divided by 2, and that gives us a number of 5 meters per second squared. Never forget to include units in your answer. Now, the next question I have for you is how can an object actually accelerate, okay? And we identify three main ways for it to happen. Number one is when the object is speeding up. So let's say from 5 meters per second, let's say from 5 meters per second to 10 meters per second. When the object slows down from 10 meters per second to 2 meters per second, in all of these cases, we have acceleration. But there is a third one, which is kind of neglected among classroom discussions. And it has to do with the fact that acceleration is a vector quantity, which means if you want to create acceleration, you need to change what? You either need to change the magnitude, okay, so the velocity, the magnitude of velocity, or you can also change direction, and that's the key here, which means if a car is approaching a turn, even though the speed of it, the speed will stay the same as the magnitude, okay? Just because the direction is changing, the direction of where the car is moving towards to, this creates acceleration, and we'll see next what kind of motion it creates in physics and how we study this, the so-called circular motion. Okay, so 3 ways that an object can accelerate. Number 1, speeding up. Number 2, slowing down. And number 3, keeping the same magnitude for its speed, same magnitude. So it stays, let's say, at 5 meters per second. It just changes the direction towards which it's moving. Okay, and just because acceleration happens to be a vector quantity, it depends on the direction. So if the direction changes, even though the magnitude stays the same, we do have an acceleration. Okay, because remember, it's change in velocity, and velocity is a vector quantity. Now, quite often in textbooks, we see the terms deceleration or retardation. Okay, and this simply means that the object slows down. I want you, that's my tip, to avoid these terms. Okay, because usually what happens to students is that they connect these terms with negative acceleration. So deceleration and retardation, students say automatically, oh, it's negative acceleration, so the object slows down, but it's not necessarily the case. Okay, so I want you to keep in mind that the object slows down. That's what the exercise wants you to know, and not necessarily assume that the acceleration is negative. Okay, why that is the case, we will see it in the next video. Okay, so the key here is to be able to identify the words deceleration and retardation as a synonym of an object slowing down. I hope this video has been helpful to clarify a few ideas around acceleration. If you found the video helpful, make sure to like the video, subscribe to the channel, where more and more videos will be posted on a weekly basis, and share with people who you think might find this also beneficial. Till next time.